Take tunnels, for instance. Just how important an effective system of fire protection is in this case was demonstrated by the accidents in Kaprun and the Mont Blanc Tunnel. The conditions in tunnels are difficult because of the narrow space and the unpredictable drafts. Siemens Cerberus operates an experimental tunnel in the foothills of the Swiss Alps. Here, tunnel fires are simulated under realistic conditions. The Swiss principally do research into the effects of wind on fire. Experiment number 1, without any wind. 4 liters of gasoline are ignited. From the time the fire breaks out, it takes only a few moments for the poisonous clouds of smoke to grow thicker, inch by inch, but there's still a chance to escape.
Wir sehen jetzt bereits, die kommen auf unsere Höhe hier. Wir sind jetzt hier.
You can see how they've already reached our height. Now they're level with our heads. In a minute or 30 seconds, we won't be able to see anything, and we'll be breathing in the poisonous gases. Now we'll have to bend down, so we're in an atmosphere that permits us to escape. We'd now still be able to crawl away.
Also hier noch in Kriechgang weggehen.
Robert Notes now turns on the wind machine. The air streams through the tunnel at a speed of about 3 meters a second, the sort of wind that can be found in any tunnel. The flames are being fanned. Soon, they're level with the ground. The smoke is spreading everywhere. You can see how everything becomes completely enveloped immediately. We're now in an atmosphere that's becoming dangerous because of the gases being produced by the fire. The recording made by the monitoring camera shows in real time just how quickly the poisonous smoke completely obscures the entire tunnel. No one could survive here. If you think about it, your best chance would be to run into the wind. That's where the fresh air is. The bad air is being blown out through the tunnel. Experiment number 2. A simulated car fire is being used to investigate how the wind speed accelerates the speed of the fire from the engine compartment to the fuel tank, in this case, a plastic bag. First of all, without any wind. Although the fire is started, it takes several minutes for it to spread through the passenger compartment to the tank. Time enough for the occupants to escape and for the control center to close the tunnel and call the fire service. But things are quite different when there's a draft. The fire spreads rapidly right from the start. After only 50 seconds, the entire car is ablaze, and the tunnel is thick with smoke.
Die Windgeschwindigkeit war ungefähr 5 Meter pro Sekunde.
The wind speed was 5 meters a second, and that fanned the flames very strongly.
Das Material ist etwa 3 bis 4
The material burnt about 3 to 4 times faster than in the first experiment, and it produced correspondingly more hot gases per time unit. That's naturally much more dangerous. The information obtained from experiments like these is used in the protective concepts that Siemens is developing for buildings and underground installations all over the world. Technology that locates a fire precisely, that cuts off the air supply in the right section immediately, and that extinguishes the fire at just the right spot.
Mit der automatischen Anlage können wir das Feuer im Auto.
With the automatic extinguishers, we're not able to put out a car fire, but we can create a situation in which the fire service is able to take action. You can also see that the water washes out the black smoke, so that visibility is considerably improved.
Die Sichtverhältnisse werden wesentlich besser.
Catastrophes can be avoided with the aid of intelligent fire protection technology.